Now the next important thing is monitor. This is what used in Java. So for understanding monitor, already I have given you the basics through mutex and semaphore. Now you are ready to understand monitor. So for that, I have an example for monitor. Now to understand this one, again I will take the help of mutex and semaphore. So let us look at them once again quickly. Then you can understand this easily. So look at this. This is mutex. So this is shared data. I'm not calling it as an object. I'm calling it as data, shared data. Okay. So this is mutex. Now thread 1, thread 2 want to access that. So what is their responsibility? First, lock that mutex, means shared data using mutex, read and write, and then unlock. See, basically, if a thread is accessing any data, means what it may be doing, reading and writing only. So lock, read, write, unlock. Lock, read, write, unlock. Then what is the thread 2 doing? Lock, read, write, unlock. So this accessing that shared object part is inside the thread only. This is the responsibility of a thread. So that portion is called as critical section. Already I have shown you. So critical section is inside the thread only, inside the thread, right? Now semaphore. In semaphore, for putting a lock here, the responsibility is taken by operating system. So locking, unlocking is done by operating system, and operating system maintains a queue and it will make the other threads wait. This we have already seen. So what are the elements here? This is shared data, mutex, that is locking, wait and signal are the methods, and this is a block queue. Now this is threads. What they should do? They should wait for accessing it. So once they get the lock, read, write, and inform the operating system that it has finished using it. Same way this thread is also doing this. So this is a critical section again. This is a critical section that is a part of thread and part of this thread. So they are accessing it. So they are putting a lock and accessing. So who is helping them? Operating system is there in between. So here if you see, there is nothing. So these two threads are responsible for achieving mutual exclusion. But here who is responsible for achieving mutual exclusion? Operating system is responsible for achieving mutual exclusion. Now here threads does by themselves. Operating system is involved. But reading, writing still with the threads. Now come to this. I am calling now this as a shared object and I have named it as SD. So this is a shared object. This is having data or resource data. See, this is the data. This is the data. So data is here. Then mutex is here only. So along with data. And the read, write methods are also along with that data only. Reading, writing methods are with the data only. Then the queue is also with the data. So it's a complete object. So entire mechanism is there with the along with the data. So together entire thing I am calling it as object. This is an object. So object in terms of object-oriented programming, not in general terms, object-oriented programming. So an object in Java will contain data and the methods on the data. Yes, everything is there together. Now how threads will access? Threads will just say read for that object, SD, I am calling it as SD. SD read, SD write. There is no locking, unlocking. It is built in inside. This is the mechanism available here, right? So locking and unlocking is taken by that object itself. Then what threads are calling? Just the method. They don't have the procedure here how to read and how to write. So these read and write method belong to the object. They belong to the object, not doesn't belong to a thread. So how to read and write? Object itself knows that. So this thread is also calling read and write. This is also calling read and write. The object itself takes the responsibility of achieving mutual exclusion. So the complete mechanism is inside the object. There is no operating system involved here. So this type of mechanism is provided by Java. As Java is object oriented, so this concept came into picture once the object oriented programming language started evolving. So monitor is the example. It can be achieved using object orientation. So Java supports object orientation. So simply you have to use some keyword called synchronize, and Java puts this entire mechanism in that object. So it's very easy. Achieving this is very easy. You don't have to do anything. You don't have to make a queue and everything. Just you have to use the keyword synchronize. So we'll see that in example. Once again, we'll look at it as a conclusion. So we'll look at all of them. Just watch again once again. See here, threads knows how to log, how to read and how to write, how to unlock. Thread knows everything and it's the responsibility of thread. How to read and write, thread knows it. So these methods belongs to thread, right? Belongs to thread. Then here, thread knows how to read and write, how to read and write. Then who takes the responsibility of locking and unlocking? Operating system, but threads request for them. Here there is no request for unlocking and unlocking, and the thread doesn't know how to read and write. The methods are available in the object itself. So what you want to do, just do it. Say I want to call this method so and so read method, so it will take care. If it is available, it will allow you to access. Otherwise you have to wait in a queue, and once your turn comes you can access it. So this was loosely linked. Threads were independent, right? And this is the only connection point between two threads, that is mutex. But here it is managed by operating system. Operating system take care of it. So threads are accessing it under the control of operating system. But here object itself is controlling it. So thread doesn't have any responsibility. Just they will try to access it. If they are allowed to use. Otherwise they have to wait. Just like in a barber shop, saloon, hairdressing saloon, you entered in and you want to get your hair cut, or just you want to shave your beard, whatever it is. So whatever the method you want to call, you will enter in and call. And if it is available, seat is available, you are allowed to sit and you are serviced. Otherwise you have to wait in a queue. And once your turn comes, he will call you and he will give you service. That's it. It is just like a closed shop. Everything is there inside. So that's all about this monitor. So I'll explain these things through an example code also. In the demonstration I will give you this one. So that's all in this video, and we will see inter-process communication and race condition in the next video. Next we will see race condition and inter-process communication.